Lesson 3.2, Writing Expressions. In this video, you learn to use variables to represent numbers in algebraic expressions and write algebraic expressions. There are words in the English language and phrases that indicate certain mathematical operations that you need to be familiar with. These are just some of them. When you hear the words added to, plus, sum of, more than, increased by, total of, and, that indicates addition. When you hear subtracted from, minus, difference of, less than, decreased by, fewer than, take away, that indicates you need to subtract. When you hear multiplied by, times, product of, twice, and the word of, that indicates you need to multiply. And when you hear divided by or quotient of, that indicates that you need to use division. These are things that you need to commit to memory so that when you're working on real life problems or in algebra, you'll know which operation you actually need to use. Example 1, writing numerical expressions. Write the phrase as an expression. So A, 8 fewer than 21. So fewer than are our indicator words. And if you go back to that chart that we had, fewer than means to subtract. But you have to be a little bit careful with the subtraction words because we don't necessarily go in the order that you see this here. So if you think about it, 8 fewer than 21 means we're going to start with 21 and subtract 8 because it's 8 fewer than 21. Part B, the product of 30 and 9. The product of indicates we're going to multiply. So we could write this a few ways. We could write 30 times 9, which we're not going to really be using an x a whole lot anymore because we're moving into algebra. And in algebra, we use an x more often than not as a variable. So I would like you to start using one of these indicators for multiplication. A dot, or you could use parentheses, or if it's a letter, you can just write it right next to the number that you're multiplying it by. But we can't do that if it's two numbers, because then it would look like 309. Example 2, writing algebraic expressions. Write the phrase as an expression. So numerical expressions deal with numbers. Algebraic expressions deal with variables in algebra. So part A, 14 more than a number x. So more than indicates addition. So we'll write 14 plus x. It says a number x because x represents a number. We just don't know what number it represents. Part B, a number y minus 75. Okay, so in this case it's saying the y comes first and then minus 75. Part C, the quotient of 3 and a number z. Quotient of means to divide, so 3 divided by z. Or remember, fractions are also division problems, so we could also write it this way. Example 3, writing an algebraic expression. The length of Interstate 90 from the west coast to the east coast is 153.5 miles more than 2 times the length of Interstate 15 from Southern California to northern Montana. Let M be the length of Interstate 15. Which expression can you use to represent the length of Interstate 90? So let's look at our keywords here. The east coast is 153.5 miles more than 2 times the length of Interstate 15 from Southern California to northern Montana. So we're looking for an expression out of these choices, A, B, C, D, that has addition and multiplication in it. Okay, so if I look across here, A has multiplication and addition. B has multiplication and subtraction, so that's out. C has multiplication and subtraction, so that's out. And D has multiplication and addition. So I'm looking at A and D. So 153.5 miles more than 2 times the length of Interstate 15. So I'm going to be multiplying 2 times the length of Interstate 15. I don't know the length of Interstate 15 because it says right here, let M be the length of Interstate 15. So it's going to be 2 times M. I don't know the length of Interstate 15, so we have a variable for that. So I'm looking for one that has 2 times M, and then I add on 153.5 miles. So that's going to be A. That's the one where I have 2 times the length of Interstate 15. That's M that I don't know. Then I add on the 153.5 miles to that. Example 4, real-life application. You plant a cypress tree that is 10 inches tall. Each year, its height increases by 15 inches. A. Make a table that shows the height of the tree for 4 years, then write an expression for the height after T years. What is the height after 9 years? Okay. So at 0 years, at first, it's already 10 inches tall. Every year it increases by 15 inches. So after 1 year, I can add 15 inches to that. So it's going to be 10 plus 15, and that's 25 inches. So year 2, it's going to be the last one that I started with, or 10 plus 15 times 2. And that's going to equal, I have 15 times 2, which is 30, plus 10, and that's 40. After 3 years, I have the 10 that I started with, plus, now I have 15 inches times 3 years, and 15 times 3 is 45, plus 10, that's 55 inches. After 4 years, 10 inches I started with, plus the 15 inches it grew over 4 years. Okay, so that's going to be 60 inches. That's the 15 times 4 is 60, plus another 10. That's 70 inches. Okay, so what is the height after 9? So when I actually make my expression here, look at what's changing each time. I have the 10 stays the same each time. The 15 stays the same every time. But the 2 and the 3 and the 4, that's always the year. So if I write an expression and say 10 plus 15 times t, I should be able to plug in how old the tree is by years and figure out how tall that tree is going to be. So for part B, let's say after 9 years, 10 plus 15 times 9. 9 times 15 is 135, plus another 10, that's 145 inches.